Hi guys, and welcome to the Physical Sciences course for Year 10 of the Australian curriculum. This explanatory video we're going to be running through the concept of kinetic energy. Okay, so this is the first video which is going to be running through what are the different types of energy and how do we use them. Okay, so kinetic energy is basically the energy of a moving object. So basically if an object goes from A to B, it's got kinetic energy. Now there's a variety of different things which are going to be involved in determining how much kinetic energy something's got. So if I pick up this pen and I drop it, it's got kinetic energy. Okay, the ability for it to move from one point to the next allows it to have that type of energy. So wherever we've got movement, we've got kinetic energy. So it's fairly straightforward. Now obviously the amount of energy will vary. Now there's two main variables which are going to control how much kinetic energy is present in an object. The first one is the speed. The second one is going to be the mass of the object. Now the speed works on an exponential graph curve, so it actually gets faster. So basically, if you've got an object which is going slowly, the result is only going to have a very small amount of energy. However, if you've got an object which is going incredibly fast, like a bullet, then we've got a lot of kinetic energy. Okay, anything which is stationary, i.e. is not moving, has no kinetic energy, because as you can see at the top, kinetic energy is the energy of a moving object. Okay, so slow, small amount of kinetic energy, fast, large amounts of kinetic energy, not moving at all, has no kinetic energy whatsoever. So this pen has no kinetic energy at the moment. It has the potential, but at the moment there is no kinetic energy because it's not moving. Now the second variable is the mass. Now basically it works on a proportionality constant that basically as the mass increases, so does the kinetic energy. So the heavier you are, the more mass you've got, the more kinetic energy you've got when you are moving. Obviously, if you're not moving, as it's stated earlier in my explanation, if you're not moving, you can't have any kinetic energy. Now, mathematically, we'll show that in a second. Okay, but the concept is that as your mass gets bigger, you get a greater kinetic energy, but as your mass gets smaller, you have less kinetic energy. Fairly straightforward. Okay, well let's look at the two scenarios that we've got down here. It's also in the iBook, which I've explained in text, but I'm going to discuss it in concepts with respect to mass and speed. Okay, now let's look at the cyclist here. Now the cyclist only has a small amount of mass. I mean, let's say it's an average male, around about 75, 85 kilos. Okay, bike isn't going to be too heavy, so you've probably got a maximum mass there of, let's say, about 90 kilos. That's it. Now, a bike can go really, really fast. I don't know what the maximum speed at which a bike can go, but it would be around about probably between 40 and 50 kilometers an hour, maybe faster, but you know it can't go too fast. So we've got 90 kilograms, and it could probably go to a maximum of 50 kilometers per hour. Let's use that as an example. Okay, 90 and 50. Let's take the bus. The bus is going to be way heavier than the cyclist. So if the bus was going at 50 kilometers per hour, it's probably got, what, a couple of tons fully loaded, 2,000 kilograms. So we've got 90 kilograms and 50 for the cyclist. We've got maybe 2,000 kilograms and 50 for the bus. Which one's going to have more energy? Obviously the bus is going to have more kinetic energy. So the mass and the velocity have an effect. Now, let's put the cyclist, 90 kilograms, 50 kilometers per hour, against the bus, 2,000 kilograms, but it's only going at, let's say it's stationary. The bus is not moving. The cyclist is going to ride straight into the back of the bus. The cyclist still will not have enough energy really to do any damage to the bus. Okay, because we've got 90 and 50. You look at those numbers, there's not a lot there. The bus is so big, the mass is so big, then the energy on that mass is going to be very, very small. Let's take the other scenario. The cyclist is stationary. The bus is going at 50 kilometers per hour, 2,000 kilograms. So you've got 2,000 kilograms and you've got 50 kilometers per hour. Huge numbers. If that bus hits that cyclist, there's not going to be a huge amount left of the cyclist. Okay, so what I'm trying to get over to you is the concept that mass and speed are the variables which put together to make kinetic energy. Now, it's not as simple as just saying add the two together or multiply the two together. There is a relationship which has been formed. There has been studies being done between mass and velocity, and it has been graphed. And from that, what we get is the following equation. The kinetic energy equals 1/2 times the mass times the velocity squared. Okay, it's important that you understand that the velocity is squared. So the kinetic energy, or Ke, is measured in joules because it's energy. That makes sense. The mass must always be measured in kilograms. So please, 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 when you get to a question, make sure that the units for the mass say kilograms. Okay, if they don't, you are going to have to convert. If it's in grams, you're going to have to divide by 1,000. Okay, it's probably the main way it's going to be. So you're going to have to divide by 1,000 if you're in grams. If it's in kilograms, you're all sweet as. The velocity is measured in these units, meters per second. Now, meters per second can be written ms to the -1 or ms or m/s. It means meters per second. This is the amount of distance. It goes in meters every second is what it stands for. Again, you may have to convert between kilometers per hour and convert that into meters per second. Check out the iBook. It's there for you, and there's a variety of different kinetic energy problems there which I've run through to explain how to work that together. So let's have a look at a little problem. So we've got a sample problem here where we've got kinetic energy of an object with a mass of 10 kilograms. Notice it's in kilograms, so it's all good. Traveling at a speed of 2 meters per second. So 2 meters per second, that's good as well. Okay, so all the units are the same. So what I always get people to do, write down what you know. We know the kinetic energy, we know that the speed is in meters per second, and we know that the mass is in 10 kilograms. So then write down the formula. Now the formula is 1/2 mv squared. So what do I put into my calculator? I put 1/2 times the mass, which is 10, times the velocity squared. Now velocity squared is the same as the velocity times itself. Okay, so if you've got a scientific calculator, then obviously you can just hit the number and then the square button, which is the x with a little 2 on top, or you can put in the velocity times the velocity. Okay, don't do it times 2. Okay, in this case the velocity is in times 2. Don't ever do the velocity. Let's say the velocity was 4 and you want to do 4 squared. It's not 4 times 2, which is 8. It's 4 times 4, which is 16. So you can see there's a problem there. And the result is that you end up with 20 joules. So that's a very simplistic question of using kinetic energy and being able to convert kinetic energy into, mass and velocity into kinetic energy. If you were to take our scenario with the bike traveling at 50 k's, we'd have 1/2 times the mass. I said it was 90 kilograms times the velocity. Now I'd have to convert the 50 kilometers per hour into meters per second to get the kinetic energy in joules. Okay, so it's really, really important that you convert that, but it would be 50 kilometers per hour, whatever its derivative is, in meters per second squared. Okay, well, I hope you found that useful. Go and check the iBook for some of those harder questions. I've run through it step by step, so it's really easy for you to follow. And then there's an exercise 1.2 in the iBook, which you can then go and try out. There will also be a practical video, just sort of demonstrating what kinetic energy is, and just gives you a flavour as to what's going on. If you have any questions, by all means have a word with your teacher. It's really important that you're aware of this formula and being able to use it. You will be given the formula in the exam, so you don't have to remember it, you just have to be able to use it. Okay, well, thanks for watching, and join me again when we're looking at another form of energy in the next video. Thanks for watching.